Okay. Good morning, everyone. Welcome to this morning class. Okay. You are welcome to this morning class. How was your night? Hope you are good. In this video, we'll be looking at differentiation from first principle, which we are going to differentiate tan x, sin x, and cos x. Differentiation from first principle. I'm going to teach you how to differentiate tan x, first principle. Okay. Calculus, right? Okay, yeah, everybody should look at the board. Should look at the board. It's okay. It's simple as ABC. Is that clear? You don't need a prophet to tell you. Differentiating a function from first principle is simple as ABC. All of us will know how to differentiate, generally, two of us. But now, they said we should differentiate a given function from first principle. So, here, let's fix idea with an example. Differentiate y equals to tan theta from first principle. Amen. Okay. Yeah. So I want you to look at the board. Let's look at the board. Differentiate this from first principle. As simple as ABC. Okay, look at it. As long as first principle is concerned, the formula for first principle is this: y plus increase y equals to f of x plus increase in x. This is the formula. Amen? So this means that okay, since we are dealing with theta, the independent variable here is theta, so here will be theta. Is that clear? Theta. Amen? Theta plus increase in theta. Is that clear? So far, so good. So, what you need to know first is this. Here we have f of theta plus increase in theta. Then y is given as what? Tan theta. So this implies that this theta represents theta plus the theta, while this f tan is your f. Is that clear? So the coefficient of theta is tan. So likewise, the coefficient of theta plus the theta is f, true or false. So if you want to present this here, if you want to present tan theta using first principle, this is how it will be, it will look like. It makes our y, amen, plus the y is equals to tan open bracket theta plus increase in theta, amen. Are you following? Hope you are following. Okay, so if you can see what I am saying, you don't need the prophet to tell you. You don't need the prophet to tell you. It means we are going to subtract y from both sides. If we subtract y from both sides, this is what we are going to have. dy is equals to tan open bracket theta plus d theta minus y. Then, what is your y? Your y is given here as what? Tan theta. So our dy is equals to tan open bracket theta plus the theta minus tan what? Theta, because our y is tan theta. Amen? Okay. So, if you agree with me, you know, when we have tan open bracket theta plus theta, let's go back to our trig formula E. You know that they make use of tan sometimes theta 1 plus theta 2, true or false? Talking about two angles, isn't it? Okay. So you know that the formula for this is given as equals to sin theta cos the theta plus cos theta sin the theta all over cos theta cos the theta minus sin theta sin the theta. Yeah, do you agree with me? Okay, sorry, instead of okay, since we are talking about theta plus the theta, so here will be the theta, right? So this is how it's supposed to be. But supposing here is theta 1 plus theta 2, that is when you would have make use of cos theta 1, sin theta 1, cos theta 2. Then cos theta 1, sin theta 2. Is that clear? Please take it. So, if you agree with me, it means this is equal to this, and likewise, tan theta is also the same thing as well, sin theta all over cos theta. Amen? Amen. Okay? So far, so good. Let's proceed. You can see what I am saying, both in the spirit and physical. Okay. So far, so good. So it means instead of tan open bracket theta plus increase in theta, you are going to write this. Then instead of tan theta here, you write sin theta all over cos theta. Is okay. Let's okay, here will be dy is equals to sin theta cos the theta plus cos theta sin the theta. Amen. Then all over cos theta cos the theta minus sin theta sin the theta. Amen. Now what we have here, minus theta, and theta is known as what? Sin theta all over cos theta. Amen. Okay. So if you agree with me, you don't need a prophet to tell you, just like when we have A all over B plus B all over C. When you come across an expression of this one, you don't need a prophet to tell you. First, you consider what? The LCM, right? And the LCM of this, B and C, you either use this to multiply this, use this to multiply this, and use this to multiply. So C times A is AC plus B times D is BD, then all over B times C, BC. True or false? So that is what we are going to do here. Now look at it. If you can see what I am saying, both in the spirit and physical. Amen. Okay, use this cos theta to multiply this left hand side. Then use this cos theta cos the theta minus sin the theta to multiply sin theta. Is that clear? Okay. So far so good. Let's proceed. So far so good. If you can see what I am saying, so this implies that our dy is equals to cos theta open bracket sin theta cos the theta, then plus cos theta sin theta, amen, close bracket, minus sin theta, open bracket here, cos theta, cos the theta, minus sin theta, sin the theta, amen. Then all over cos theta times this, all over cos theta times open bracket cos theta cos the theta minus sin theta sin the theta. Amen. Hope you are following. Okay. So if you agree with me, okay, if you agree with me, oh yeah, Van Vey, where are you watching from? Which country? You said, bro, it is a simple right tan theta equals to sin theta all over cos theta, and apply quotient rule. No, we are differentiating from first principle. Is that clear? We are differentiating from first principle. So we cannot apply quotient rule. Is that clear? Which country are you watching from? It's okay. Yeah. So if you can see what I am saying, this is dy is equals to, let's multiply these brackets and this one. If we multiply these brackets, we are going to have this times this, I'm going to have sin theta, cos theta, cos theta, true or false, then plus cos theta times cos theta, cos square theta, sin theta. Then use this minus to open this bracket, minus. If you use this to multiply this, you are going to have sin theta, cos theta, cos the theta. Amen. I use this minus to multiply this, you are going to have plus sin square theta, sin the theta. Amen. Yes, all over, you can leave this cos theta, open bracket, cos theta, cos theta, minus sin theta, sin the theta. Amen? Do you agree with me? Do you agree with me, right? It's okay. So far, so good. Let's proceed. Let's proceed. I think I can clean the upper left side. Okay. Let me clean this up. Okay. So if you can see what I am saying, amen. You don't need a prophet to tell you this and this can cancel. This is positive, this is negative, right? So this and this will go. It means we are going to be left with this and this, right? So our dy is going to equals to cos square theta sin dx and plus sin square theta sin dx. True or false? Yeah. Then all over cos theta, open bracket, cos theta, cos the theta, minus sin theta, sin the theta. Okay? Do you agree with me? Okay. So if you agree with me, this is the same thing as if you look at the numerator, something is common. True or false? What is common? What is common here is sin the theta. True or false? So you factor it out. Sin the theta, open bracket, cos square theta plus sin square theta. Amen? Sin square theta. Then all over cos theta, open bracket, cos theta, cos the theta, minus sin theta, sin the theta. Amen? Hope you are following. Okay? Yeah. Hope you guys are following. Okay? So if you are following, don't need a prophet to tell you. I want us to know at this point that notes that cos square theta plus sin square theta is equals to 1. That is trig identity for you. So I think I can take off this part. Okay, so far so good. So it means here will be what? 1, and 1 times sin the theta is the same thing as. So therefore our dy is equals to sin the theta all over cos theta open bracket cos theta cos the theta minus sin theta sin the theta. Amen? Yeah. So at this point we are going to divide 2 by divide through by the theta. So if we divide through by the theta, the left hand side will be dy all over the theta equals to sin theta all over the theta, then all over, amen, I think I can take off this part, all over cos theta open bracket cos theta cos the theta minus sin theta sin the theta. Amen. Okay. So I want us to note that sin the theta all over the theta is equals to what? 1, right? So therefore this will be 1, then dy all over the theta now be equals to 1 all over cos theta open bracket cos theta cos the theta, amen, minus sin theta sin the theta, close bracket. So far so good. At this point we are going to introduce what is called limits. Amen. So as limit the theta tends to 0, it means anywhere you see theta, the theta, you write 0. I think I can take off this part, right? Okay. So here will be our dy all over the theta is equals to 1 all over cos theta open bracket cos theta cos the theta, anywhere you see the theta you write 0 open bracket 0 minus sin theta sin the theta is what? 0, right? Close bracket. So you now press your calculator. Cos 0 is 1, then sin 0 is 0. 0 times sin theta is 0. So it implies that our dy all over the theta is equals to 1 all over cos theta open bracket cos theta. Amen. Okay. It means here will now be our dy all over the theta is equals to 1 all over cos theta times cos theta is cos square theta. Okay, now you go back to your trig identity. Note that sec theta is equals to the same thing as 1 all over cos theta. So this implies that sec square theta is the same as 1 all over cos square theta. So therefore, this is the same thing as a final answer dy all over the theta is equals to sec square theta. So whenever you differentiate tan theta, generally you are supposed to have sec square theta, and this is how to differentiate tan theta from first principle. You have any question, please ask before we proceed. You have any question, ask before we proceed. Yeah. Hope you are following. Morning. Morning. It's okay. So let's consider how we can differentiate sin theta from first principle. Amen. Okay. Yeah. So far so good. Here will be sin theta. Y is equals to sin theta. Right? Okay. So far so good. We write solution. Our first principle formula is given as f of theta, since the independent variable is theta plus increase in theta. So far so good. If we subtract y from both sides, f of the theta plus the theta minus y, then our y is what? Sin theta. So our dy is equals to, as explained, you equate it with this f of theta plus the theta, then this is sin theta. So your coefficient of theta is sine. Y of theta is this, then sine is f. So instead of f, you write sine, open bracket, instead of theta, you write theta plus increments. Theta minus our y is given as what? Sin theta. Do you agree with me? Okay? Yeah. So that is that. Okay? So far so good. So let's go back to our trig formula E. Is that clear? Our trig formula E, trigonometric formula E, that notes that if we have sine, open bracket, theta plus the theta, this is equals to sine theta cos the theta. This is cos the theta plus cos theta sine the theta. Take note. Okay, so instead of this, we are going to write this here. So here will be the y is equals to sine theta cos the theta plus cos theta sine the theta, then minus sine theta. Amen? Sine theta. So looking at this equation, you can see with me that this and this are like terms. Why? Because we have sine theta here, but we know that we have cos the theta, but here is sine theta. So we collect like terms. When we collect like terms, here will be cos theta sine the theta, then plus you write sine theta cos the theta minus sine theta. True or false? True or false? Look at the board. True or false? It's true, right? It's okay. It is okay. Yeah. So our dy is equals to cos theta sine the theta plus what is common here, look at it, sine theta. You factor it out, open bracket, cos theta minus 1, right? But this time this, you get back this time this, you get back this, okay? So far so good. So at this point we divide 2 by what? The theta. Amen. Divide 2 by the theta. Amen. Okay. So our dy all over the theta is equals to cos theta sine the theta all over the theta, then plus sine theta, open bracket, cos the theta minus 1, close bracket, all over the theta, right? Okay. Yeah. So if you can see what I am saying, we now introduce limit as limit the theta tends to 0. I think I can clean this up. Tends to 0. Tends to 0. Anywhere we see this. Okay, but excuse me, at first let us know that sine the theta over the theta is 1, right? Yeah. So our dy all over the theta is equal to, this is 1 times cos theta is cos theta plus sine theta, open bracket, cos the theta minus 1, close bracket, all over the theta, right? So we now introduce limit as limit the theta tends to 0. It means our dy all over the theta is equals to cos theta. Ordinarily, if you differentiate sine theta, you are supposed to have cos theta, 2 of us. So plus sine theta, open bracket, cos. Instead of d, we write 0, cos 0 minus 1 all over the theta, right? I want us to know that cos 0 is 1. So here the 1 minus 1 all over the theta. Then this is equal to 0 all over the theta, which is 0. So 0 times sine theta is 0. You can now see that our final answer now equals to, our dy all over the theta is equals to cos theta. Any question? Do you have any question? Do you have any question? Ask. No question. It's okay. So we can proceed further to differentiate cos theta. Okay. So let's proceed that we are going to consider tan sin x cos x. That is, we are going to differentiate these 3 functions from first principle. So let us consider y equals to cos theta from first principle, right? So we all know our formula, y plus dy is equals to f of theta plus the theta, because the independent variable is what? Theta. Here will be, if you subtract y from both sides, our dy is equals to f of theta plus the theta minus y. Then our y is given as this. Then our cos theta we equate it with this, then the whole equation will now be cos open bracket theta plus the theta minus cos theta. True or false? It's true, right? Okay, so we now go back to trigonometrical formula E. So note that if we have cos open bracket theta plus the theta, this is equals to cos theta cos the theta minus sin theta sin the theta. Take note. Is that clear? Okay. So far so good. So instead of this, we write this. So our dy is equals to cos theta cos the theta minus sin theta sin the theta. Amen? Then minus cos theta. So we are going to do the same thing. This and this are like terms, so we take them. Ordinarily, if we differentiate cos theta, generally we are supposed to have minus sin theta, true or false? So when we collect like terms, this equation will now be in this form: cos theta cos the theta minus cos theta, true or false? Then minus sin theta sin the theta. Amen? So what is common here? Something is common there. So our dy is equals to cos theta is common, we factor it out. Cos theta open bracket cos the theta minus 1 minus sin theta sin the theta, right? Okay, so far so good. At this point, we divide through by dy. So the theta, sorry, dy all over the theta now equals to cos theta open bracket cos the theta minus 1 all over the theta, then minus sin theta sin the theta all over the theta. Is that clear? Amen? Look at the board. Look at the board. Okay. So, if you can see what I am saying, yeah. So, we now introduce limits. Is that clear? As limits, the theta tends to 0. It means our dy all over the theta now be equals to cos theta open bracket cos 0 minus 1 all over theta. Already our sin the theta all over the theta is 1 times sin theta is sin theta. True or false? Look at the board. Look at the board. True or false? Then this implies that here cos theta, cos 0 is 1, so 1 minus 1 0. Divide the theta is 0. 0 times cos theta is 0. So you can now see that. Therefore, our dy all over the theta is equals to minus sin theta. So this is how to differentiate tan theta, sin theta, and cos theta from first principle. If you have any question, drop it in the comment section. Thank you and God bless you. Love you guys. Bye. Yeah. Please don't forget to share